What's up, everyone? How's it going today? Today we have a 13 minute 56 second atomic model theory and history. I need this for a science project. STRIVE Collegiate Academy, right? You see, it's a pretty good science place, but yeah, they make you do this type of stuff. Anyway, this is probably unedited or anything. You see, it's 3:58 on February 10th. Yeah. And we're talking atomic theory. Anyway, first atomic dude we got was in 400 BC, right? 400 BC. This dude, his name is Democritus. He created the Lego model of the atom. Pretty important dude, right? You see, he created the Lego model of the atom. Yeah. Lego model of the atom. He said atoms are uncuttable. You see, he also said atomos means atoms cannot be cut. And they're the smallest piece of matter. Atoms of different elements are different. Obviously, this was also said by some other people. Atoms are made of a single material. Atoms made of a single material that is formed in different shapes and sizes. Yeah. Anyway, so then we have the next dude on the list. His atomic model was obviously Legos. You see, then people believe this man we call Aristotle. Aristotle was from 300 BC to 1800. You see, his theory was accepted by everyone he knew and loved. Yeah. Aristotle. Aristotle was a pretty cool boy. Yeah. Aristotle was pretty cool. You see, Aristotle did the following. He said that Democritus was wrong, Wrong, boy. Boy, was he ever wrong. He said atoms are a 4x4 grid, right? They got 4 properties and can be made of 4 elements, right? So 4 properties and 4 elements. He said elements were fire, air, water, earth, and the 4 properties were hot, cold, dry, and wet. So obviously that makes sense. Fire would be both dry and hot, while water would be cold and wet. Earth would be wet and dry, while water would be, wet and dry also. Yeah, he was a smart man. But you see, he was wrong. He caused this thing we call the death to chemistry, which is pretty important. But, he killed chemistry altogether. Yeah, he killed chemistry. Moving on. We got then in the 1803 category, we got John Dalton with his Bullard-Ball atomic model, right? He was pretty intelligent. You see, he was a British school teacher and chemist. He was a British school teacher and chemist. Yeah. He was a British school teacher and chemist. Said substances of the same atom are the same, while different substances have different atoms. He also said, atoms cannot be divided, created, or destroyed, you see, or rendered, or whatever. Then his buddy, J.J. Thompson, his friend, J.J. Thompson, right? Yeah, bruh. His friend was like, yeah, boy. So in 1897, his British scientist named J.J. Thompson, proved Dalton wrong by his experiments with a cathode ray tube. But anyway, Dalton's atomic model was a Bullard ball. Anyway, so J.J. Thompson proved Dalton wrong with his experiments with a cathode ray tube. He proved that there are electrons inside an atom. You see, J.J. Thompson's experiment, or proof, was, J.J. Thompson's proof was pretty cool. He said that he created something we call plums in pudding, or the chocolate chip cookie model. Chocolate chips. You like chocolate. Yeah. So, cookie, the dough inside the cookie is positive because, it's healthy. Meanwhile, the chocolate chips are negative because, they're not healthy. So he created the chocolate chip cookie model. In 1897, while exploring with the cathode ray tube. Meanwhile, his students, his prized possession, his Asian pupil, his British pupil, in 1909, former student of Thompson called Ernest Rutherford, right, designed an experiment to study the parts of an atom. He aimed a beam from radium. He aimed a beam of radium from a lead box at gold foil, and discovered the nucleus, the center, the mass, the holder core of the atom. You see, he discovered the nucleus. He also discovered that electrons fly around the nucleus, building on Rutherford's ideologies of the electron. You see, building on Thomson's, not Rutherford's, Thomson's discovery of the electron. Rutherford built on Thomson's discovery of the electron. You see, he was a pretty smart dude. He also found a positive, small assembly nucleus, which was small, dense, and positively charged, because, it caused the particles to bounce back, and that made it pretty positively charged, you see. We got 7:21 in the video. It's 4:05 p.m. Pretty important to read through this. You see, Rutherford also discovered some other things. He discovered that electrons scattered around the nucleus at a distance. So Rutherford's atomic model was a pit, cherry pit, right? A cherry pit, a cherry with a pit, the cherry being positive and the atom itself, and then the pit being the nucleus. Now, after Rutherford, he experimented with some particles. In 1911, he revised the atomic model, and he was quite a joke. In 1913, on February 10th again, at 4:06 p.m., Niels Bohr, this guy wasn't quite a Bohr. He was more or less an unintelligent human. He was Danish, right? So, he was Danish. He worked with Rutherford, thought he was cool, because, he working with a British dude. But then, Bohr discovered something cool by shooting light at atoms for some reason. He was an intelligent young man. You see, he discovered that electrons travel in energy levels. Energy levels. So, he discovered that electrons travel in energy levels. He also made the planetary system of electron. He played the planetary system of the atom. Energy levels are located certain distances away from the nucleus. And, he stopped the nucleus because, the nucleus was going to, if there weren't like this, If it wasn't for Bohr's model, you see, Rutherford's model, because the electrons are negatively charged and the nucleus is positively charged, the atom would collapse in on itself, because it's all empty space, which makes some sense. But then this guy, Bohr here, says that they have, you see, electrons start to behave like a wave, a circular wave, particularly. And as they gain electrons, they jump to the outer layer of things. Yeah. See? Yeah. After Bohr, we got Schwarzenegger, the German dude with his dead and alive cat, his cat that's both dead and alive. We got Heisenberg with his uncertainty principle, can't find the place or the velocity of an electron, really didn't know what he was doing, pretty smart dude. You see, then you got Albert Einstein, who's a pretty cool Gucci. He was a Gucci belt. You see, Albert Einstein was a Gucci belt. Yeah, he was a Gucci belt. E equals MC squared. And, yeah, there are more scientists in the 20th century upper-level mathematics and physics. 20th century physicist. Yeah, they all added to the cotton ball model. The cotton ball model, which says there's generally an electron range where electrons belong. Yeah. Anyway, I hope you all understood atomic theory, which, yeah, I'm doing this presentation for my school at STRIVE Collegiate Academy, and, like, probably I'm going to put the address in the description, probably. What's this beeping noise? Probably going to put the address in the description. But, yeah, hope you all understood. Basically, all of the things you all need to know. Pretty simple and straightforward. Democritus thought that matter is composed of atomos. Matter is made of atomos. Dalton based his theory on observations on how elements combine, and said that atoms could not be created, destroyed, or, divided. Thompson discovered an electron inside the atom. Rutherford discovered that atoms are mostly empty space with a dense positive nucleus. Bohr proposed that electrons are located in levels at certain distances from the nucleus, and the electron cloud model represents the modern theory of atomics, or the modern atomic theory, if you will. Yeah. This video has been sponsored by nobody, right? Except Mr. Haynes, bruh. He's paying me for this work. I'm tired. It's Sunday actually, February 10th, 4:11 p.m. And hope y'all enjoyed the vid. Like, comment, share. We got a couple more seconds left because, again, this was Gucci. Apparently, this was supposed to be cool. Hope this uploads in time. Like, I'm serious. I hope this uploads in time. Yeah. Atomic theory is always interesting. Science and math are always interesting. Yeah, you could probably close right about now. Got 16 seconds left in this vid. Alright. 10. 6. 3. 2. 1.